Wilton is a small village of approximately 500 residents, some 4 miles north of Pocklington. Thanks to big lottery funding, Bishop Wilton Hall is now a new multi-purpose facility set at the foot of the scenic Yorkshire Wolds. It has been built both as a central hub for local community activities, as well as an idyllic venue for broader educational, business and recreational use. In August 2008, the village officially received an award from the Big Lottery Community Buildings Fund. This allowed the old and dilapidated village hall to be replaced by a new building on the existing playing field. The new hall combines the village hall with the sports pavilion. Its eco-friendly, flexible design offers a safe, comfortable and adaptable building facility which can easily accommodate a wide variety of needs. The area is off gas, and there were concerns about both the cost of oil and the possibility of theft, which led the group to consider renewable energy. Ground source heating was the choice, and the hall's heating costs are more than 50% cheaper as a result.
I'm Steve Swire, and I'm chair of the charitable trust that was responsible for building this hall that we're sitting in, which is Bishop Wilton Hall. Bishop Wilton's a small village in East Yorkshire, population about 500, living in about 200 houses.
Prior to the village hall, what was here?
We had in the village a very old village hall, 125 years old. It's just fallen into complete disrepair, so latterly there are only two groups using it, the parish council and I think the gardening club. There were two of us who drove the build. I drove the management process, and my colleague, who is a professional project manager and resident of the village, drove the technical management of the build. We then took the key decisions as a trustee group with the involvement of the wider operating committee. Okay, so this is the ground source heat pump. It's taking in fluid from big slinkies that are buried outside the building, and it's acting like a refrigerator in reverse. So where you'd feel the warmth behind a refrigerator and the cold inside the refrigerator, this is taking the warmth, putting the cold back out into the ground. And it's utilising that couple of degrees difference between the surface temperature and the temperature of the earth 2.5, 3 feet down where the slinkies are. It's as simple as that, really. From this ground source heat pump, the warm fluid that comes out, it goes into a number of manifolds. These are the manifolds down here, which are controlled by thermostats around the building, and so the whole building is thermostatic controlled. The manifolds just open and close and provide liquid into the underfloor heating, and there you go. This is hot water. This thing here is just the expansion tank, and the pumps that you see down here are for the showers for the sports equipment as well. So what this is doing is providing all the heat for the building completely, is providing all the hot water for hot wash hand basins, kitchen use and whatever, and all the hot water for the showers as well.
Is it supplemented in any way?
No. Well, I say no. There is an immersion heater in here that kicks in for a couple of hours once a week just for Legionella control, but it's not part of heat. It's not part of the planned heat supply. A bit of a hum, but it's completely non-intrusive. You know, once we're outside and close the door, you can just about hear it running in conditions of complete silence. So it's a very silent means of heating the building.
What made you choose this system?
Oh, well, did we choose it or was it forced on us? I mean, I can
you
be
tell me.
Honest about this. We wanted as a design group, we wanted absolute simplicity because we're dealing with a village hall here and people want nothing more complicated to be able to turn a light or a system on or off. We can't have gas. The nearest gas is in Pocklington, which is 6 or 7 miles from here, so we weren't laying a gas pipeline. We didn't want oil on site for all sorts of reasons to do with security and the cost of oil, if nothing else, and conventional boiler we didn't want roaring away into the night. And a conventional electric heating system wasn't going to work for us because the building regulations were not going to allow us to have a conventional electric system. So we really found ourselves at ground source heat pump, almost by default in the early days, and very wary of it. But the building technical designers and the architect that we used were very confident that they could do a job for us. There's no servicing, there's no user adjustable parts to it at all. There's no servicing at all. If it breaks down, that's some issue for the future. We just phone our contractors. There's fault guides on the wall. We just phone our contractors. But it's as simple as that. We took it over and it's just run like this for 2 years now. This is the master thermostat, and the rest of the building is zoned. Each zone has a thermostat which is linked to this one, and so we can vary each zone by plus or minus 4 degrees on where this one is set. Our major funder was Big Lottery Fund, the Community Building Fund, and one of the outcomes that we agreed with them for letting us have the money was that we'd reduce energy consumption by 50% on a square metre versus square metre basis, old versus new. And the ground source heat pump, all the calculations, projections said we'd do that comfortably, and that has indeed proved to be the case. My only reservation would be, where do we go if something technical goes wrong with it? Because whereas if you've got a conventional heating system, you can call a plumber in and he'll flush it out and get you going again. If this system goes down, it's 24 to 36 hours before you notice it's gone down for a start, because the temperature falls away very gradually. It's driving someone, and the other one is down at the end of the room, the building. That's my reservation, but we've not got enough experience operating it to know whether that's a major consideration or just a minor issue. I can tell you that the total energy cost for running the building at the moment is coming out at just over £4 a day in the current fairly mild winter we're having. So we're able to predict our energy costs very accurately, and for this year our energy costs will be somewhere between £1,200 and £1,500. Now that's all energy. That's heat, lighting, hot water, the air circulation equipment, and 20% VAT, because we class as a commercial operation.
And this is all coming from your ground source heat pump?
All from the ground source heat pump, yeah. We've just stuck a finger in the air and said, we think this will last 10 years. We think the windows will last 15 years. And to say we're budgeting for it would be too scientific, but we're accumulating funds. The strategy we're working to, the first is revenues to cover running costs. The second part of the strategy is a sinking fund that we're developing for future repairs and maintenance through fundraising. And the third part is volunteer support to engender a sense of ownership rather than having paid staff. Ground source heating is 3 years old now, and people know a lot more about renewables now than they did 3 years ago. So all of us travelled in good faith.